All right, welcome everybody. This is our lecture on atoms and atomic structure. Okay, so this is when we're going to first be kind of rigorously introduced to atoms and what makes them up and how they define elements and stuff like that. Okay, so this part, it's not in your notes, but I just wanted to go over the kind of tenets of modern atomic theory, sort of the things we understand about atoms right now. So number one, all matter is composed of atoms. Okay, everything that we know that other than light and things without mass is composed of atoms, and specific atoms make up specific elements. Okay, our second point, atoms are sort of the basic building blocks of everything. They cannot be subdivided, created, or destroyed in ordinary chemical reactions. We can do this in nuclear reactions, which we will get to later in this unit, talking about radioactivity. But for chemical reactions, like what we talked about, where you're creating a gas or changing color or increasing the heat or something like that, where you're kind of like pouring, doing classic chemistry, pouring acids and bases together or whatever, that's never going to split an atom into halves or destroy an atom into its component parts or something like that. Number three, atoms of an element have a characteristic average mass, which is unique to that element. I wouldn't worry too much about this, but just elements have a specific atomic mass, which we will get to. And then number four, crucial, atoms of any one element differ in properties from atoms of another element. Okay, so if I were to be able to sort of look at an atom of sulfur or some whatever element you pick, I should be able to distinguish them in their number of protons and other things from an element, from an atom of chlorine or hydrogen or boron or something like that. Okay, you cannot have two atoms that look the same but are different elements. Okay, so here, let's start the notes. So, atoms, I'm sure you've seen pictures like the one on the right here. There's lots of ways to draw an atom, but basically they're all going to involve two main parts here. So, you've got the nucleus in the middle, right? This is where neutrons and protons are. It's at the center of the atom, and it's where all the mass of the atom is. Okay, because as we'll discuss, I believe on the next slide, neutrons and protons are way heavier than electrons. Okay, so that's the first part. The second part is kind of this stuff around the outside, and this is called the electron cloud, also sometimes called electron orbitals or orbits. It's the area around the nucleus. It's mostly empty space, but that's where the electrons are. They kind of orbit around the nucleus, or they, more accurately, they kind of just like hang around outside the nucleus. They don't go in the nucleus, they kind of hang around outside of it. And electrons, they do not have very high mass, as we will see. Okay? So, proton, neutron, and electron, what are we talking about here? So these are the three things that make up atoms. Okay? Protons are this sort of red circle on the left here. Okay. The main thing to know about protons is that they are positively charged. Okay, you can sort of have a mnemonic for that, right? Protons, they start with a P, so it does positive. Okay. They have a mass of one atomic mass unit. An atomic mass unit is more or less defined as the mass of a proton. And they're found in the nucleus, as we discussed before. By the way, the two protons and neutrons that are both found in the nucleus, these are also referred to as nucleons. That's not in your notes, but just thought I would mention it. Neutrons, however, as you can probably guess from the name, are neutral. They do not have a charge. Okay, so protons, they have a charge of +1 per proton. Neutrons have a charge of 0 per neutron. okay? But they weigh basically the same as a proton, 1 atomic mass unit, and are also found in the nucleus. And then last, the electrons. The electrons have negative charge, okay? Protons positive, neutrons neutral, electrons negative. They have a charge of -1, so if you have a proton and an electron in an atom, they will cancel each other out, right? Because this will be +1, this will be -1, they'll add to 0. Electrons have an extremely small mass, it's around 2,000 times smaller than the proton, and they're found in the electron cloud, they're not in the nucleus. Okay, so those are our 3 basic building blocks there, and every atom is made of at least the proton and the electron, but almost all of them have all 3 of these. Okay, so we've got some extra little, I guess, vocab to know about atoms here. Okay, the first one we're talking about is the atomic number. Okay, this is defined, it's very simple what this is defined at. This is just the number of protons that are in an atom. Okay, the reason this is called the atomic number is because elements are defined by the number of protons that there are. Okay, so up here we've got chromium. Okay, so that's an element on the periodic table, it's sort of in the middle. It's a metal. And the atomic number for chromium is up there in the upper left, 24. That means that every single atom of chromium will have 24 protons in its nucleus. It can have a different number of neutrons, as we'll discuss later, and it can have varying number of electrons, but chromium is literally defined as being made up of atoms that have 24 protons in them. And that's why this atomic number is important. Okay, next up is the mass number, and this is also very simple. It's just the number of protons, aka the atomic number, plus the number of neutrons in that specific atom. Okay, so that's the number of nucleons, if you remember from the previous slide. And if you need to know the number of neutrons just from these 2 things, right? So we've got the atomic number, which is just the number of protons, and the mass number, which is protons plus neutrons, right? If I subtract this from this, that gets rid of the protons and just leaves the neutrons. So the number of neutrons is equal to the mass number minus the atomic number. Okay, but we will practice that later. And then lastly here, the atomic mass. This literally describes the mass of one atom of a certain element. Okay, we don't need to know too much about it, but it's this number down here at the bottom for chromium. And the reason it's not a whole number, right, because you can't have half a proton or 0.996 of a proton or neutron. But the reason this is a decimal number is because it's an average relying on different isotopes. Okay, so the 2 main things to know here are atomic number and mass number and how they're defined. Okay, so speaking of isotopes, an isotope just describes the different kind of versions of one element depending on the number of neutrons in an atom. Okay, so a classic example is carbon. Okay, so this is carbon 12, right, because it has 6 protons and 6 neutrons. That adds up to 12. Okay, this is carbon 13. Oops, 13. This is carbon 14. Okay, so crucially, see that the number of protons is staying the same, right? And remember, that is because if we change the number of protons, it won't be carbon anymore. Okay, it'll be nitrogen if we add one. But the number of neutrons can change. Okay, and carbon 14 is kind of important because that's what's used for, I don't know if you've seen this term, carbon dating looks at the number of carbon-14 in sort of old samples of rock and fossils and stuff like that to try to figure out how old it is. We'll talk about that later in the unit when we talk about radioactive decay, but basically just know that when you have something written out here like, boron 12 or something like that, this is the element, and this describes the isotope of that element, but what the number actually is the mass number. Okay, so for carbon 13, it's 6 plus 7. For carbon 14, it's 6 plus 8. Okay? So, isotopes, same element, different number of neutrons. Okay, just want to introduce nuclear symbol notation, right? If we were going back to talking about carbon, okay, carbon 12 would look like this, right? Because carbon has 6 protons and 6 neutrons normally, and so you add those together, you get 12, and that's the mass number up top. But carbon 14, remember, which was used for carbon dating, still has 6, right? Because it's still carbon, but up here it would have a 14 instead of a 6. Okay. And then lastly, I just want to talk about ions. Ions are what happens when you don't have the same number of protons as electrons. So let me explain. So if I have an atom that is neutral, okay, that means that for every proton, which gives a +1 charge, the atom has a matching electron that negates that +1 charge with its own negative charge. Okay, so if I had, let's stick with our carbon here. So I've got a nucleus with 6 protons and 6 neutrons in it. And then I've got the electron cloud out here, right? I should have 6 electrons out here if the atom is neutral, right? Because I should get +6 from the 6 +1s from the protons. The neutrons are all 0 charge, so they don't matter. Okay, so the nucleus will have +6, but the 6 electrons will give us -6, which should add up to 0. Okay, so hopefully the math makes sense there, but really all you need to remember is that for a neutral atom, the number of electrons is the same as the number of protons. Okay, but they don't have to be equal. Okay, so if I had carbon, so if I were to write it like this, carbon +1, okay, that means it's an ion now because it does not have an equal amount of protons and electrons. And this +1 means that it has a total positive charge of 1. Okay, and so what that means is that we still have the 6 protons here because it's still carbon, but instead of 6 electrons out here, we only have 5, right? And so we have +6 minus 5 gives us +1. We have an unbalanced charge of +1 because we have 1 fewer electron than we do protons. Okay, this number can technically be anything, right? We could have carbon -2. These are all very unlikely to actually exist, but carbon -2 would mean that we have 2 more electrons than we have protons. So looking at our picture up there again, that would be 8 electrons. Okay. And that is, the entire concept of an ion. If they don't match up, if it's not neutral, it's called an ion. And just a little bit of vocab here. Cations are a positive charge, so that's like carbon +1. Anions are a negative charge, that's like carbon -2. Yeah, and that's just a brief sort of introduction into atoms and atomic structure. I believe That's all I've got. Yep. And yeah, we will have ample time to practice this and think about how we can draw atoms and calculate the different numbers in class. But that should be a good introduction for now. Okay, so I will see you in class.